At this point in the module, you've seen how spatial models work and why model choice matters. This paper was written in response to some articles that were critical about how spatial econometrics were being used at the time. So it sharpens one of the most important ideas in spatial econometrics, that not all spatial models generate spillover effects. This is something that we haven't exactly talked about yet, and a lot of the readings you've done have kind of hinted at it, but has not specifically focused on it. So even though models like the SAR, the SEM, and the SDM all include spatial dependence within the model, they don't all imply that a change in one region affects other regions. So when you really want to be sure you're using the appropriate model for where your spatial dependence occurs, and you need to interpret it correctly. So what they do in this paper, and why I think it's so important to include, is that it separates spatial dependence in the data, which is something that would require you to use a spatial model in general, from spatial spillovers, which requires you to use a specific type of model. And these are not the same thing, spatial dependence and spatial spillovers, even though it's easy to think so. So spillovers will only occur if there's a specific kind of spatial structure in the data. So it's cases where either the dependent variable or the explanatory variables influence the neighbors. This means that some spatial models can detect the spatial dependence, but it can't model the actual spillovers between units. When the spatial dependence is in the error term, that's not a big deal because there are no spillovers from your variables. And that's when we use the spatial error model, the SEM. Really effective when there is some spatial relationship that you're not able to capture with any of your variables. But using the SEM, this is an issue if your research question is about diffusion, interaction, or about policy effects across space. So I'll touch on models very quickly. They go into more detail in the article, of course. So SAR, the spatial lag model, you use this model when the Y, the outcome variable, depends on the neighbor's Y or their outcome variable. This model is able to generate spillovers. Same thing for the SDM, the spatial Durbin model. You use this model when you expect Y and some of your covariates to be spatially correlated. This model, again, also generates spillovers. But the SEM, the spatial error model, this does not generate spatial spillovers. You use this only when the error term has spatial autocorrelation. Now, they also go on to argue that the W matrix is important and it should be based on which units interact. So they say to base this on theory instead of trial and error. What some people were doing at the time was defining the W matrix different ways. So, by border contiguity, by inverse distance, by I guess, contiguity to the second degree, so neighbors and then neighbors' neighbors, things like that, and then seeing which one provided the best, like the lowest standard error is the best fit of the model, that kind of stuff. But that's really the wrong way to go about it. They say that it should be based first and foremost on the theory of how the regions and units interact with each other. That's what's most important. So don't worry about choosing the wrong W that doesn't minimize standard errors or provides the best fit. So regional questions almost always involve spillovers like tax competition, migration, housing markets, job growth, policy diffusion, tons and tons of different questions that we answer in regional economics. But you need a model that accounts for these spillovers properly, and it has to be appropriate for where these spillovers are occurring. So if your research question involves interactions between regions, you need to be choosing between the SAR and the SDM model, not the SEM. The spatial error model is something you only use when there are very specific types of regional interactions, and this is going to be in the error term. And then if you want the most flexible starting point, spatial Durbin, the SDM is almost always the safest choice to start from.